let's officially start trigonometry. Okay, I hope you remember today. Lots of neat things are going to be said, but of course, lots more to come also. So, trigonometry. Now, I want to take you to the Garden of Eden of trigonometry, so to speak, kind of where it all began, and that is the unit circle. The unit circle is actually a really simple circle. I doubt you're going to forget it, but make sure you notice it's got a radius of 1, and it's centered at the origin. Now, if it has a radius of 1, it makes it easy to find some points. And how'd that go for you? These are just x and y values that we're talking about. Of course, if you move 1 unit, then your x value should be 1. But you have not moved in the y direction. But if you move 1 unit up, then your y value should be 1. And so how'd you do here with some of these points? Okay, now what's happening here is we're using the x and y axis along with a circle to start to think about some angles. And what I find is that kids, they, for some reason, are so mesmerized by this circle. It's so amazing. It's so wonderful that they just want to freely express how they feel about it. And I want to give you full permission to do that. For some reason, it seems that every time I say unit circle, that students will spontaneously yell out, "I love the unit circle." And so let's practice that. Every time I say unit circle, you may spontaneously yell out, "I love the unit circle." All right? And so please feel free to do that. Of course, it's kind of fun and just something a little cheesy to remember this. By the way, I'll have kids come back in calculus. We start talking about the unit circle, and somebody yells out, "I love the unit circle." We got to feel the love a little more in here. Now, you say, "I don't know, Miss Neal, I'm not sure if I love it yet." What's the big deal? There's angles that go with these points, yes? Like 90 degrees. Oh, 90 degrees goes with that point, and all the other angles you see. In fact, any theta, any angle will go with any unique point, xy. Now, I would jot that down, but make sure you listen because I'm going to repeat something which is really why you're going to love the unit circle. So I just want to make sure you don't miss it. Jot down what I drew. But I want to say something to you again. So here's the thing. And by the way, I don't know, maybe I didn't have a real good high school experience. I'm not sure. I never really realized this until I started to teach it. But I want you to realize it. Any theta, any angle is going to intersect this unit circle. It's going to intersect it at a unique point, xy. In other words, if I rotate to another angle, there's going to be another point. And here's the thing. That's the only point that will go with that angle. In other words, every angle has a unique point. Now, in mathematics, that is a function. Let me say that again. In mathematics, that's a function. What I mean by that is when you input an angle, you will always output a unique point. And when we have a function, we have something. We actually have a lot of something. In this case, what we have are called the trig functions or the trigonometric functions. And to say it again, the trigonometric functions will take an angle, which is an input, and they will output a point. They will output x and y. Let me show you the trigonometric functions. You've actually seen them before. But what I want you to be careful about is that you don't kind of, when I write them down, say, oh yeah, I know what that is. I'm trying to take you back to the theory of trigonometry, which we're going to use like all semester. And so you may have seen these before, but most kids, if they're honest, say, yeah, but I didn't really know the theory, and that's what I'm going to be teaching you. So we have the cosine function. Now the cosine function will take a theta. And by the way, you would read this as the cosine of theta. So like I'm inputting an angle. Now you can go back to my sketch here. You can look at this angle. That's why I drew it. Because if I input this angle into the cosine function, I'm going to output the x value of that point. And again, here's the thing. That's the only x value that will go with that angle. Okay, that's because it's a function. That's because it's an input, a unique input to give a unique output. There's a sine function. I'm sure you've heard of it. But the sine function takes an angle like theta and it outputs the y value of that point. And here's the thing. That's a unique relationship. When I input theta, okay, the y value that goes with it is unique. Now, these are abbreviated, which sometimes those look more familiar to kids. If you abbreviate them, we knock off a couple letters and we say it's the cosine of theta equaling x and the sine of theta equaling y. It's nice if you still pronounce them, though, cosine and sine. So those are the trigonometric functions. Now, here's a little footnote here. X and y are on the unit circle. X and y are on the unit circle. All right, thank you, Julia. Okay, maybe say, all right, I think it sounds good. I think I got the idea. So, what do we start to do with this? Okay, well, you came to the right place. What we can start to do is we can start to find some values of sine and cosine. We call them trig values. And it's actually going to be our main adventure for the next week or so. We're basically going to use the unit circle to find trig values. Okay, but what you're going to find out is that I will give you different starting points. Okay, but here's a good starting point. Like if I give you an angle. So if you're given an angle and I want you to find a trig value, what will we do? Well, we will look to none other than the unit circle. The sine of 90. Just sort of a little by the way, sometimes when I write that down, there's a cracking open of calculators. And I see some of you have a calculator. That's fine. What I want to share with you is that we're really going to approach this without the calculator. In fact, I'm kind of purposely not even going to say anything about the calculator. So if you punched in your calculator and you maybe got an answer and it's going to be different than what we get, I'm actually kind of purposely saying, hey, don't worry about it. Because I actually don't want you to use your calculator. Okay? It's for your own good, I promise. We will get the calculator fired up in due time. But right now, I just want you to go to 90 degrees. And if you go to 90 degrees on the unit circle, you should be focused on this point. Now, of course, this point has an ordered pair, 0, 1. So what we need to do is grab the right one. And of course, sine is defined as y. So I think that's our y value. So when I write down the number 1, what I'm really writing down is the y value at 90 degrees. Listen to that again. When I write down the number 1, I'm writing down the y value at 90 degrees. That's not too bad. So could you do the cosine of 90? So when you write down 0, you're writing down the x value. You're writing down the x value at 90 degrees. And of course, it's not an oh, by the way, but it's an always. It's on the unit circle. Now I did something here. I changed the type of measurement. I changed the measurement to radians. And in your brain, you kind of have to convert. You kind of have to think, okay, this is in radians. So you go to pi. Now, when we say go to pi, that's an angle. Okay, and that angle intersects at this point. And eventually you grab the x value. So if you wrote down -1, you are correct. So we use the x value at pi. See how this works? You have an angle, takes you to a point, and then the sine takes you to the y value. Okay, now, sometimes at this point people say, okay, eventually we're going to exhaust all these zeros and ones, right? Yeah, eventually we're going to exhaust them. Can we do some other angles, like something besides a multiple of 90? Yeah, I'm glad you asked. Maybe like 45 degrees. And I'll sort of share with you here that if we're going to do 45 degrees, like the sine of 45, we might as well do the cosine also, because we're going to be basically focused on a point. We can do both. I'm going to zoom in on quadrant 1. Okay, so see what I drew here? Part of the unit circle. Here's 45 degrees. And that point right there, well, that's where our focus is. Okay, that's our desire. If we could just find that point, then we would have sine and cosine. What do you guys think? What do you think about the x and y value of that point? I know, it's kind of, we just started, we've only been on it for less than 20 minutes, but I'm just kind of curious. Any speculation, sort of a guess? Genevieve? Okay, maybe it's like at a half. Any thoughts on the x value? Maybe it's also a half. I don't want to put words in anybody's mouth, but maybe. What definitely would be true about that x and y value? It would have to be less than 1. It would have to be less than 1. If you were at that point, that's a really good point to be. Okay, because if you just think about the reality, this distance here is 1, 1, 0, and up here is 1, 0, 1. So this point is definitely somewhere in between 0 and 1. Is it halfway? What is equal to 1 in regards to this point? What distance is equal to 1? Do you see it? Maybe it's hard to say it, but do you see the distance that's equal to 1? Now, it won't take too long for you to catch on to this, but I kind of need to show you. that an x and a y value is really like a component. It's kind of like a horizontal component. It's kind of like a vertical component. Now, let that sink in a second, because I know I just drew something. You're saying triangle. Right. I mean, it's a triangle. But what I really want you to notice is that the components, the legs of this triangle, are actually my x and y measurements. Okay, so again, just want to make sure you see this, that when I talk about like a horizontal measurement, that x measurement would be the same as the x coordinate of this point. And of course, the y measurement, this vertical distance, would be the same as my y coordinate. So did you see what's just happened? We've taken the conversation from where's the point? We've taken the conversation from where's the point to what's the value of the legs of this triangle. Okay, so we're going to go seek and find the legs of this triangle. And of course, that's going to give us the point. Triangles. Triangles. What do you remember? What do you notice? What's true about this triangle? We actually have this hypotenuse already labeled as 1. That's a great start. Is there anything else that's true about the triangle? Right.
The top angle would be 45 too.
Which now affirms that we have what type of triangle? Well, a 45, 45, 90. What do you remember about a 45, 45, 90? And anything special about that right triangle? Good, we can use Pythagorean Theorem. Now, that's exactly what we're going to do, but here's the problem. If I use the Pythagorean Theorem right now, which we're going to use it, but if I use it right now, I have two variables. And just so we realize, our goal is to find x and y, but this is going to be hard to find x and y because there's two variables. Anna?
Are x and y variables would be equivalent?
Now, if something's equivalent in math, we can say so. We can say so by naming them, by letting them equal another variable. I'm going to let them equal a. Okay, just because they're the same. By the way, that's just kind of a fact from the past that in a 45, 45, 90, like Alyssa's saying, that as Anna added, the legs are equal. But look what that does to Pythagorean Theorem. It allows us to have an equation that says a squared plus a squared equals 1. And the truth is that's an equation that's solvable. It's got one variable. I guess we just need to get to business solving it. So a squared plus a squared is like having two a squareds. Keep solving for a. You're going to divide by 2. Keep solving for a. Just by the way, remember, solving for a is like solving for x and y. And x and y, just so we remember, is really the goal of this problem. It's sine and cosine. So we're really on the right track here because we're about ready to find a. Now, the square root of 1/2, what are you going to do with that? Well, maybe think back to some of your etiquette with square roots. You can do the square root of the top. You can do the square root of the bottom. The problem there is that you get a square root in the bottom, so that's a no-no. And so we'll take the square root and we'll kind of rationalize it up to the numerator, which means that you're going to end up multiplying root 2 to the top and root 2 to the bottom. And so we get something that's a little bit more proper. We call it root 2 over 2. Root 2 over 2. Here's the main thing, though. That's x. That's y. That's our point. And most importantly, that's sine and cosine. Interesting. What is the size of root 2 over 2? What is the actual value of it? If you pop it in the calculator, I know I said we're not going to use a calculator, but if you pop it in the calculator, you get 0.7. 0.7. Again, it's kind of like, really? I guess it's not a half. Well, even if you look at the way I drew the sketch, a half would be more like right here. And so it's a little bit past a half. To get to this point, it's a little bit past a half. So actually, even visually, it makes sense that it's a little greater. But it indeed is very interesting. Okay, and remember that this represents the y value at 45 degrees, and this represents the x value at 45 degrees. Okay, and that's the only x and y value. Like next time we do the problem, I know it's kind of obvious, but next time we do the problem, that point is going to come out to be the same. That's because 45 degrees matches with a unique point. Now, what you guys are going to learn is that trigonometry is a bridge. It's a neat bridge, okay? It's a bridge that's actually kind of circular. So you get up to this gap, and the gap is algebra on one side and geometry on the other. And so the way that you bridge algebra and geometry is by crossing the bridge. But it's a circular bridge. And my little joke is honestly that the unit circle connects algebra, which are points, to geometry, which are angles. And I want to make sure you get the idea that every angle has a unique point, and that's a connection. And that opens up a whole world of math that we're going to spend 3 months talking about. Okay, this is just the beginning. But I'm excited to begin the journey with you. All right. There's no formal homework. You may have noticed that from the board. Just come back tomorrow and have a good day.